Hello. Today we solve a question from SSSCE called Mathematics 1997 Objective Question 40. And it reads this way. In a class of 20 students, 16 play soccer, 12 play hockey, and 2 do not play any of the two games. How many students play only hockey? A, 10 students, B, 8, C, 4, and D, 2. Before we start, if today is your first time on my students class channel, don't forget to subscribe and click the notification button so that you'll be promptly informed anytime we upload a new video. And hey, one more thing, click the like button so that the video can reach a lot of people. Thank you. Now let's continue. Now we are talking about class of students doing one sport or the other, and we are seeing only soccer and hockey. So this gives us the idea that we are dealing with two set problem, and to do that we can use the Venn diagram, or we can also use some sort of expressions to do that. So the first way to do this, or one method or approach to do this, is to use the Venn diagram. So let me try to gather some few data here. In a class of 20 students, so we are talking about, so let me say, let U be equal to what we are talking about, that is students. I can say students in a class, and of course the number of students in the class, the number of the universal set I'm told is 20. Now I'm talking about soccer here, so let me use R so that I can easily identify what I'm doing here. So students who play soccer, so all right, students who play soccer. Of course, in an objective question like this, there is no need to write all these things. I'm only writing these things so that you understand what I'm talking about here. So students who play soccer, and of course we were given the number of students, so the small n means the number of students in the set S, because I've used the set S to denote the number of students who play soccer, and we are given the number 16. 12 play hockey, so the word hockey starts with H, so if I use H, it will be very easy for me to identify the set, so I'll use H. Students who play hockey. Okay, so from here I can be looking at the number of elements or students who play hockey, and I'm told they are 12. Do I have another information here? Of course I do. And 2 do not play any of the two games. So that is what we mean, that is what we call complement, because they are not in the set, they do not play. So they do not play any of the two games. It is not that they don't play soccer or they don't play hockey. They don't play both soccer and hockey. So this means that if I put soccer and hockey together, that is S union H, they are not in this set. If they are not in this set, then they will be in the complement of this set, because the complement means not in the set. So the number of students who are not in who are not playing soccer and hockey is equal to, we are told it is 2. Okay, here. So how many students play only hockey? So we have to find only hockey, and if you want to write only hockey, that is how we do it. The number of students in soccer complement intersection hockey is what? That is what we have to find. That is only hockey. Because it is only hockey, the S here is made complement, so that means it is not in S but it is only in H. Of course, so I can draw my Venn diagram here. So let me draw some 2 circles and proceed from here. Okay, and let this be my soccer circle. So the number of students who play the soccer, from here I wrote NS is 16. The number of students who play hockey, which is h. From here I wrote 12, and of course the universal set, I can't forget this, the number of students in the universal set is also 20. And I was given additional data, the number of students who do not play any of the two. That is, if I combine S and U, that is the whole of this, the number of students outside S and U is 2. So let me use a different color to illustrate this here, so I can put a 2 anywhere here. So that is what it means. Now this is what I have to find. I don't know it. So well, do I know the number of students who play the two games? Of course I don't. So I can choose any variable, so let it be x. So let me put something small here, the number of students who play S, and then h, that's S intersection h, let it be x. So I began doing something here. I could have written something like let's here, because I am, choosing my own letters to represent the student category. So I could have written let U be students in a class, let S be students who play soccer, let H be students in that. So that is that. So I'm going to write, if that is the case, then I'm going to put S here. Now the entire circle, this entire circle, the number of students in this entire circle, that is the number of students who play soccer, is 16. Now out of this 16, part of it is x, so the remaining will be 16 minus the x. You get it? And then here to this entire circle, the number of students who play the hockey is 12. So if part of it also play if x number of their students who play hockey also play soccer, that is what it means here. So the entire H circle, part of it is x, so the remaining is 12 minus the x. Okay, but I'm told that the whole of this universal set, the number of students in this is 20. So that gives me a very nice or perfect equation. So I can add all the terms within the Venn diagram and equate it to 20. So I'm going to have something like 16 minus x here, this term, plus the second term, that is plus x here, plus this term, that is plus 12 minus x here, plus this term, that is plus the 2, should be equal to 20. So this has now boiled down to a simple linear equation that I'm going to simplify. If I have negative x and positive x here, then that means the negative x can cancel the positive x. So let me look at this. 16, so I'll have something like this, 16 plus 12. Let me group the like terms. So I'll bring the 2, then I'll put the minus x here, equals 20. So let me do some addition here. This plus this, yeah, 28 plus 2, I'm getting 30. So I have 30 minus x equals 20. And I can decide to send, I have to group like terms here. I can do two things here. I can decide to leave the x here, but be very careful, the x is negative. So if I leave the x here, I have to write negative x. And on the right hand side, I have 20 already here. And if I send the 30 to the right hand side, because I'm grouping like terms, the sign of the 30 here is positive, so it will change to negative here. So I'll have negative x equals, if I subtract 30 from 20, I get negative 10. Be very careful, you are subtracting a bigger number from a smaller number. In other words, this sign here affects the 30. The sign of the number 20 is positive, so 20 minus 30 is negative 10. I am finding s, not negative x, so I have to divide both sides by negative 1. And by so doing, the value of x will be 10. Normally, I tell students to try to dodge the negative sign. So from here, I think what I would have done, or I would have asked you to do, would have been this. Let me take it from here, just here. 30 minus x equals 20. Why don't we send the negative x to the right hand side, so that the sign will change to positive x, so that we will not be dealing with negatives, because many students have problems with negatives. On the left hand side, the 30 is already there, so we bring the 20 to the left, and this time around we have minus 20. So we will have the opportunity to subtract a smaller number from a bigger number, and that's not a headache for us, of course, because when we subtract 20 from 30, we get 10, and we have 10 equals s. If 10 is equal to s, then x is equal to 10. That is it. So the value of x is 10. So the number of students who who play both sports is 10. But be very careful. What is the question asking you? Look at the option A. Option A is 10, but the question is asking you to find how many students play only hockey, not those who play both. If the question had asked you about those who play both, the right or the correct option should have been A10. So anytime that you solve a question, be very careful and ask yourself, what is the question asking of you? The question is asking of only hockey. So where is the hockey circle? There is the hockey circle. Only hockey means we don't want those who play hockey and soccer. So only hockey, that is the region. Only this part. We cannot add this X because here we have the soccer part here. So only hockey is only hockey. The term there is 12 minus X. And of course, we have found the value of X. X is 10. So if X is 10, then only hockey will be 12 minus the 10. So the correct answer is the 2. So be very careful anytime that you solve a question. Don't rush. Check very well and ask yourself what you are defining. So that is the correct answer. That is D, and that is the number of students who play only hockey. All right, so there is also an alternative way of solving this. We are told that in a class of 20 students, 16 play soccer, 12 play hockey, and 2 do not play any of the 2 games. How many students play only hockey? What if we do not want to use Venn diagram to solve this? We can solve this without using Venn diagram. Let me put out the data. The number of students in a class, that is the universal set, is 20. 16 play soccer, so the number of students who play soccer is 16. 12 play hockey, so the number of students who play hockey is 12, and 2 do not play any of the 2 games. So let me look at the number of students who do not play any of the 2 games. So that means that if I unite their 2 sets, I'm talking about a complement of the 2 sets. That is the number of students in S union H R complement, and that is 2. Now there is a function, or let me say an expression that I can use to do this. The expression is the universal set is equal to the number of students in, or the number of students who play soccer, plus the number of students who play hockey, minus the number of students who play both hockey and soccer. But I have to add those who do not play any of the 2. The number of students in S union H R complement. Yeah, I'm doing this because if you looked at the Venn diagram very well, you would notice that we had something like this. We had S here, H here, X was 16, H 12, but we had 2 also here, and of course we had to subtract the intersection, because of the fact that if we don't do that, we will count them twice, because these are people who are playing both soccer and also hockey. I think in one of the formulas, in one of the questions that I solved, instead of writing this, we had 2 sets. We had a set A and B. Let me use the set S and H as we have here. It would have been something like this: S union H is equal to the number of elements in S plus the number of elements in H minus the number of elements in S intersection H. So why am I now using the universal set? Now in this instance there is no complement, but the moment there is a complement, then you have to consider the entire universal set, because considering only the union of this means that you are neglecting the complement. So that is the reason why I didn't write the number of students who play soccer and hockey. Instead I wrote the universal set. Of course this is equal to this, if there is no complement, but here there is a complement, so I have to be very careful. Now the universal set is 20. The number of those who play soccer is 16. Number of those who play hockey is 12. Number of those who play none of the two games, I don't know, so let it be x. So let me put x there, minus x. And the number of those who do not play any of the two games, that is s, h complement, is 2. So let me simplify this. 16 plus 12, I'm getting 28, plus 2, that gives me 30, minus x. So as I did say, I don't want the negative, so I will send it to the left hand side. I will have the x here. The sign here will change when it crosses the equal sign to positive. I have 30 here already, so I write it. I bring the 20 here. I have negative 20. So when I subtract 20 from 30, I get 10. So there was no need writing, drawing the Venn diagram. So there was no need drawing the Venn diagram and using the Venn diagram. I just found the value of x, but x is the intersection. But I'm asked to find the number of students who play only hockey. So this is the tricky part that you have to see. Now the entire hockey, I'm told entire hockey is 12, and I'm told the intersection of the hockey and the soccer is also 10. So if I want only hockey, then I have to take out the intersection, which is the 10, so that I get 2. So the answer becomes the D. So that is an alternative way that you can also use to find the number of students who play only the hockey.